Okay, hi guys. So we need to go over some angle rules. I know we kind of go through them all the time, so we're just going to formalize what we already know. I just want to briefly go over them so you're able to obviously make a note about them, and then we can start using them within any kind of angle work that we do actually do. Okay, so just get on with it. The first one, which you might see over here, well, if you know any, you can always note them down anyway and just double check to see if we're going over them. But the first one over here, which one do you think it's about when it's kind of talking about find the sizes of these angles? And it goes, Annie draws a pie chart. What kind of rule do you think they're talking about, especially when you see these diagrams over on this side as well? So you probably notice pencil, because you're drawing a diagram. What's the one thing everything has in common? The thing they all have in common is that they are all extending from the center. So this center, or we would say a point, we would say angles around a point add 2. So let's just call them A, B, C, D because I'm not measuring them right now. So angles around a point. I know it sounds really obvious because it is. So there's a point around the point, angles around the point, add to 360, which is something that I'm sure quite a few of you are already saying. So angles around a point, add to 360. So on the worksheets I will pop on there, there will be some simpler ones. So if I just give you an example of a simpler one right now, I'm just going to have a bunch of angles here. Okay, I'm going to say this one is 110 degrees, this one is 90 degrees, and this one is 60 degrees. And I'm asking what angle X is. So if I had to find out angle X, then obviously I would say X plus 110 plus 90 plus 60 is 360. I know when we were going over the adding and subtracting, multiplication, division, and all that, and techniques to make it easier, here's a technique that makes it easier. 110 plus 90, that becomes 200. So I can automatically start figuring it out in my head without having to use a calculator. So I've got 260 that side, I've got 300 that side, so collectively I have 260 here. So I know if I have X and 260 and I have 360 this side, I am just going to cut that off, and when I cut it off, X is left as 100. Yeah, hopefully that should make sense. So that is just angles around a point, just a nice easy one just there. So if I was to look at, say, question number 4, just across there, it's asking you what angle size A and B is. So this kind of question would just need to be a thinking question. You would say, altogether, I've got 360, and there are 5 parts altogether. So if it's 360 with 5 parts, then how much is each part? They must all be equal. So you would do 360 divided by 5, which leaves me with 72. So all of them would be 72. So when looking at that question where it asks you how big size A is, A would then equal 72 because it's one of those angles. And you can do the same when you're looking at B as well. Does that make sense? So obviously the sheet I give you for the first side, if I do just show you what the first side looks like. Obviously the first part is relatively easy where you can just go through those questions, some very basic questions which were like this one right here. And then obviously going on to stuff that requires a little bit more thinking when we had to do save that one. Okay, so that is angles around a point. I think quite a few of you know already, so I would probably say quite a few of you might not start on the easy side, you might actually start on the more problem-solving side, which is okay. The next rule we want to check would be, does anyone want to hazard a guess? Some of you may have already got it. So I'll show you the first page. It makes it really, really obvious. Angles on a straight line. Okay, so angles on a straight line. Super, super easy if you are looking at your protractor. If you ever forget, just look at your protractor. It says 180 on both sides. So you can go 0 if I go from the outside, goes to 180. 0 if I go from the inside, 180. Okay, so if you ever forget what the angles add up to on a straight line, just look at your protractor. It will literally tell you what the angles add up to. Okay, so looking at that, just need to make sure you pop a note down. You might want to put 2 angles here, you might want to put 3. However you wish to do it, it doesn't matter. This would just be A, B, and C. So I would say angles on a straight line add to 180 degrees. Okay, so if I just go by, say, one of these examples, I'm just going to use that question over here, which I believe is question C. So if I have question C, I'm just drawing a sketch. So you've got 49 degrees here, and you've got angle X. Yeah, that says X. Angle X there. So I know 49 plus X equals 180. So if this is 180 and this is 49 and that's X, then I know X is going to be 180, take away that 49 just by looking at that factor family. Okay, so X will equal 131 degrees. And then obviously you have the problem solving with this one as well. So if I just check one of the problem solving ones, just so you can look at it and see how it is. So even if I looked at like 5B and it says angle A is 4 times the size of angle B. So if I was to look at that one, this, you should remember the square. The square is just a right angle. This is angle A, this is angle B. So if straight line is 180, this is 90, that means the remainder must be 90, okay? Because 180 take away 90 is just 90 degrees. And they've told me A is 4 times bigger than angle B. So this is A, this is B. So this is 4 times bigger, but altogether I know that it's 90 degrees. So I'm saying how much in each box. That would be 90 divided by 5 because there's 5 boxes, which leaves me with 18. So I put 18 there, 18 there, 18 there, and 18 here. So A would be 18 times 4. That's the same like 20 times 4. Take away 8, which is 72 degrees. And then B is 18. Okay, so you have some basic examples, but you also have some problem solving. So I would say just make sure you at least tackle a few of the questions on the problem solving side, because we have spoken about some of these rules before, so I'm well aware that you guys have seen some of these rules. So it's more of a recap than anything else, and if you do need to take notes, then obviously make sure you are taking those notes for your revision purposes. Okay, just looking at this, can anyone guess what rule it is? It is vertically opposite angles. Okay, you don't necessarily say opposite, because in opposite would be, say, if I had a shape, quadrilateral here, these two would be opposite each other. They're not vertically opposite. So when we're talking about vertically opposite, we are talking about these two lines that are vertically opposite each other. So it would be these two, or obviously it would be, so I'm going to say both of those are the same, and then these two are the same as well. So vertically opposite angles are equal. Okay, just make sure you've written that down as a note. I would always say a diagram says 1,000 words. It's very important to have a diagram. So make sure you have your pencil and your ruler and you're drawing them as you need to. Okay, so some of the simpler questions here is just saying tick the pairs of angles that are vertically opposite. So obviously you can tell these are straight lines. If they're straight lines, then it will be very easy to distinguish. If you can tell they're not straight lines, then obviously it will be very easy to see if they're not. Down here it is talking about work out the sum of the unknown angle. So if one of the angles is 29, the other one must be, is it equal? Who knows? Not like I've written anything down. Okay, and then the one down, and this one, the second one, that one is asking you to also use angles on a straight line to double check what you're doing. No, that's just a red herring. So sorry. It's just a red herring. It actually does give you a bit of a red herring. If you do check 132 plus 48, it does equal 180, so that is definitely a straight line. It's just a bit of a red herring. So sorry, even I got caught up into it. And then in regards to problem solving, you would just say, if I was looking at Whitney's question, should I talk about Whitney's question or another one? If I'm looking at Whitney's question, she's just saying it's equal because they're vertically opposite. You've just got to explain how they're not. Oh, no, sorry. The answer doesn't ask whether you need to prove her wrong. The answer is saying, do you agree? So now that you know she's wrong, how do you know she's wrong? Okay, so you might have noticed I did draw 2 straight lines. What do you notice about that diagram? That obviously is different from this one. That's all you need to talk about. Okay, so that would be angles in vertically opposite angles. That's angle rule. Let us move on. Okay, so another one they want you to know is the sum of angles in a triangle. So some of you obviously have gone over this with me. I just want to show you a very easy proof that shows the sum of angles in a triangle. Can I really see this? Can't really see this, can I? Okay, I'm going to colour these angles in just so it's easier for you to see the angles. And because my colouring in is going to be quite messy, it's going to be all over my wonderful little background just to... Right, so imagine if you have a triangle. You guys can do this by yourself. So if you get a triangle and you colour in the 3 angles, I'm going to say cut yourself out a triangle and cut yourself out a quadrilateral. And then if you just want to colour in the angles, which will make it really, really obvious as to what you're doing at the end, you can do so. So you can obviously pause this. Do it on some scrap paper that you never need to use again. So for me, I've got it on the back of some of the worksheets I used to have in the classroom. So I don't use those worksheets anymore. So now I use them for demonstration purposes. Okay, so if you've gone and cut out your triangle and your quadrilateral, this is a very, very simple proof to show you what the angles in a quadrilateral and the angles in a triangle add up to. So for the triangle, we've got our wonderful triangle right here, and all I need to do is look at the angles. So I am literally going to destroy my triangle. This is why I said you need to make sure it's scrap paper. So all I need to do is pop those 3 angles together. And what do I notice about the angles in that triangle? What do you think they add up to? Big clue. Big, big clue. Okay, so angles in a triangle do add up to 180 degrees. What I've usually done in the past is when I get people to prove this, is I get them to stick this into their book. So if you do have your book on you and you're taking the notes, you probably want to just stick it into your book and just write next to it, angles in a triangle add up to 180 degrees. Okay, they add up to 180 degrees. Quadrilateral is very, very similar. So I've got that. What do you think I'm going to do? Yeah, I'm going to rip this one off as well. Dun, dun, dun. Okay, I purposely made a quadrilateral that was not a square because it's very easy to do it with a square and you can kind of just think about it rather than actually having to do anything. I'm going to pop my angles together. So angles in a quadrilateral would add up to, so we got angles in a point add up to 360, and you notice in a quadrilateral they seem to add up to the same number of degrees. So you can do the same thing with your quadrilateral. You just need to say angles in a quadrilateral add up to 360 degrees. Okay, so just make sure you've got both of those rules written down as well, and then you can get started on some of the questions that do come up. So you've obviously got some very easy questions, but I know this is something quite a few of you already know, so I'm not expecting you to take super long on this. If you already know it, I am expecting you to work on the problem solving and then look at the more difficult ones. So although you may see quite a few worksheets, it's just because I know that a lot of you already know the majority of the rules. So all I'm expecting you to do is briefly maybe look at this side, but I am expecting you to go across to the second side and then start working on the stuff that's problem solving. So if I'm looking at those triangles, it would say identify and label the angles that are equal in each triangle. So you can start thinking about your different types of triangle rules, and then maybe once you've got the rules over there and you've just solidified those rules, and then you can apply them up here. So obviously, like say that first one is an isosceles triangle, so I know both the base angles are going to be exactly the same, and then I can work out from that. Hopefully that makes sense. Okay, and you can do the same thing with the quadrilaterals. So I will be popping on all of those sheets onto the Google Classroom just to make sure you go through them. Obviously, give yourself time to go through them, but I would say just make sure you focus on the stuff you need to. Don't go on the super easy stuff because you know you can get a lot of quantity out. I would say focus on the problem solving, so you're actually thinking about it and you're going, I know that rule, how can I apply that rule? And then solving a question from there. So that's when you actually start solidifying your knowledge and actually mixing it in with previous knowledge, and then that is what's going to get you the mastery within geometry, which is an amazing topic when you can actually start using all those rules together. And when you start using them all together, it all just makes so much sense. Okay, so I'll leave you to that, year 7. Do enjoy your day. Obviously, if you do have any questions whatsoever, please contact me. Otherwise, you can do it via the classroom. If you contact me directly, then it'll be my email or usually a private comment within the classroom. If it is just a general question to the class, just pop it into Google Classroom and just place it there. Okay, so I only did this video on YouTube because I know quite a few of you might start skipping, some of you might not start skipping, so it's all kind of dependent on that. So if you do obviously want to skip because you already know the rules, that is perfectly fine, just to allow you to get on with the work. If you were going through them to make the notes, obviously I know you're going to spend time at doing the notes, okay? So obviously do the work that is to your standard. I'm not comparing you to anyone else, I'm comparing you to the standard that I've already seen in class. So if I already know you can do something and you're doing the basics again, I will be questioning that, okay? So do take care, have a nice day, year 7.